Today we'll be solving LeetCode 64 minimum path sum. We're given a grid where each cell contains a non-negative number. We start at the top left corner and we need to reach the bottom right corner. Along the way, we can only move either to the right or down, and our goal is to minimize the total sum of the numbers we collect along the path. This is a dynamic programming problem. The key idea is that the minimum path to reach any cell depends on the paths to the cell above it and the cell to the left of it. If we know the best way to reach those two cells, then we can figure out the best way to reach the current cell. By filling out the grid step by step, we can eventually compute the minimum sum for the entire journey. Let's go through the code step by step. We begin by finding the size of the grid. Next, we handle the first row. Since the only way to move in the first row is from left to right, each cell in this row can only be reached by the one directly before it. To update this, we loop through every column starting at 1, and for each position, we add the value of the cell directly to its left. By the end of this loop, the first row represents the minimum path sums if we only move right from the start. Then we move on to the first column. Here, the only way to move is straight down from the top. So we loop through every row starting at 1, and for each position, we add the value of the cell directly above it. Once this is complete, the first column represents the minimum path sums if we only move down from the start. Now we focus on the rest of the grid. For every cell that is not in the first row or the first column, there are two possible ways to reach it, from above or from the left. We choose the smaller of these two paths and add the current cell's value to it. This ensures that each cell stores the smallest possible sum to reach that point. We do this using a nested loop that goes through each row and each column, updating the values as we go. Finally, after filling in the entire grid, the bottom right cell contains the minimum path sum to reach the destination. That's the value we return as our answer. The time complexity of this solution is O of m times n, since we visit each cell once. The space complexity is O of 1 extra space, because we are updating the grid in place instead of using a separate data structure. And that's how you solve LeetCode 64. Thank you for watching, and let's keep learning.